Hello everybody, we're getting ready to do 3.5 of SAT Math Level 1. This course includes 70 lessons, quizzes, online tutoring, tests, note-taking sheets, and homework sheets. If you need, as well as PowerPoints and video. If you need to contact me to acquire those materials, here's the email. 3.5 here, we got 48 points of notes here to take, and we got a skill sheet at the end of this lesson for 24 points. The solutions to that would be available with a solution. Overview of this section. So we got multiplication, that would be an example there, and then factoring, example there. 3 basic types of factoring that you need to know for the SAT. Factoring out a common monomial, factoring a quadratic trinomial, such as this here, going from here to here, and then going from here to here, which is the same thing. Here is a difference called the difference of a square here. So factoring the difference between two squares using the rule, here is your pattern here for factoring a difference of a square. You go to this kind of pattern. Factoring a polynomial by removing a common factor. So we factor out an 8x here. 8x is the greatest GCF of this expression here, etc. So it corresponds to 8x by 10 by dividing 24x cubed plus 16x by 8x. And then here's our algebra here where we come to this final simplified expression. So we can check that. Using factoring to isolate variables in equations, it may be necessary to isolate. So to do that, we need to factor. Isolate terms. So in this equation here, factor out x from the left side, a minus b. So simplifying terms will be easier to solve the term when you simplify them by factoring. And then these cancel out here, and x equals this quantity or this expression here. Factoring a quadratic trinomial. So what two integers when multiplied together give positive 12 here when you're factoring trinomials here. You have to always think about your C element there of a trinomial. And that's usually the key part of factoring a trinomial when A is 1. So here are the different factors when they combine, which ones add up to -7, so it would obviously be these two here. So x minus 3, x minus 4. I mean, that's kind of like the rationale that you use to factor a trinomial like this. -3 times -4 equals positive 12. Then factor this here, this trinomial here. What do we think about? Find two integers when multiplied together give a -14. So what two together will give a -14, and then the middle element here of -5. So -7, positive 2. We give it here. This would be your factoring into two binomials from this trinomial. Would this be these my binomial? Factoring ax squared plus bx when a is greater than 1. When a is greater than 1, it gets a little bit more complicated for sure. And so this is kind of like a first step here when you're factoring something like this. You know, this first a here has got to be a 3 and a 1, or a 1 or a 3, 1 or a 2. And then identify the pairs of integers that will, when multiplied together, will become 8, either both positive or both negative, but this is positive here, so they both have to be positive. So the middle term of 3x squared plus 8, 10x plus 8, you come up with this, 3x squared, 6x, 4x, and then 8. So this will be your factoring right here. That's kind of like the reasoning behind that. Check that the factors work. And then, see, for 3x squared, if you're not placed correctly, the inner product, it could become something like this rather than 10x. So you have to watch that. Factor the difference between two squares. Difference between two squares can be rewritten as this here. A plus b, a minus b. Okay, to further factor a difference of a square, which is what this is what we come up here. This is the pattern for factoring a difference of a square. Same thing here, we have a difference of a square here, and then a difference of a square here, and then another difference of a square here. So to solve this, what is the value of p plus q? So we need to solve for p plus q. We have this here, then we plug in. If x is greater than 1, p minus q equals 4. P squared minus q squared would have to equal 100. And solving from up here, solving this exponential equation here. Then factoring for this equals 100. Substituting 4 for p minus q gives this here, so 100 over 4, p plus q must equal 25. So in factoring completely here, to factor a polynomial into factors that cannot be factored further, it may be necessary to use more than one factoring technique. For example, here with these, you could factor out a 3 here, and you come up with t squared minus 25, which is the difference of a square, and then you get this pattern here. And then down here, a cube, a third degree trinomial, you factor out a t, and then you get this quadratic here, and then you can factor this further into that. And then t minus 3, that's a square, so t times quantity t minus 3 squared. Using factoring to simplify algebraic fractions. So that's another way of helping to simplify algebraic fractions, like this here. Factor the numerator and denominator. So we can factor out 2 up above, and then this is a difference of a square. This is the pattern for factoring a square. Rewrite b minus a as the negative of a minus b. So you have this here. Then those can cancel. Cancel ab since it is factor of both numerator and denominator. So we get this going on. Then we come up with this. And that would be your final solution to that. Then we have a trinomial up here. Then we have a square here minus this. Expression above is equivalent to what? And then we're trying to, once it's simplified, which one of these expressions would be equal to that. Factor the numerator as a product of two binomials and factor out the common binomial of the term x minus 1 in the denominator. So we have this here, original expression, and then we can factor this trinomial into these two binomials. Then continuing on our solving here, we come up with this fraction here. These two binomials factor out. They cancel out. Then we end up with this x plus 1 over x minus 1. So with these two here, we're trying to add those two. Which of the following is equivalent to the expression above? So actually, when you combine these two here, which one of these expressions equal this sum up here? So to add these two, we have to factor out a negative 1 here. And then to do that, we come up with this here, we come up with this negative sign here, and then we combine with 3x minus 9 over 2x minus 6. Then we can factor out x minus 3 out of both of these, a factor, and then we come up with 3 over 2. So that would be how you would do that, just by manipulating negative signs between two binomials. Okay, so again, I got support lessons for this. If you're not quite up to this, I got other algebra remediation kinds of lessons that you can get from me at this email here. Tell me what your thing is. I provide online tutoring, etc. Thank you.